Hello, my name is Robert Fromont. I'm from the New Zealand Institute of Language, Brain and Behaviour at the University of Canterbury, and this is the fifth video in a series of videos showing how to use our corpus annotation system called LaBB-CAT. In previous videos, I've shown how to install the software, how to upload data into it, how to do basic searches, and how to do some manual annotation. Now, you can configure LaBB-CAT to automatically generate annotations using layer managers. Basically, layer managers are LaBB-CAT modules that take data in one annotation layer, do some kind of computation on it, and then save the results in another annotation layer. In this video, we'll be looking at the frequency layer manager, which counts tokens of each word type over a configurable scope. We'll be looking at the porter stemmer, which applies the porter algorithm to word orthographies to compute their word stems. We'll be looking at the pattern manager, which creates annotations based on matching regular expressions against words. And we'll be looking at the statistics layer manager, which computes aggregated information, like word count or duration over groups of words. Now, the first thing we have to do is start up LaBB-CAT. We'll just double click on the LaBB-CAT icon, and that starts up the mini web server that it runs. Once it's up and running, the web browser will open at the right place. Now, LaBB-CAT comes with a number of layer managers pre-installed. You can see a list of the installed layer managers by clicking on the Layer Managers link on the menu. You can see there are a number of layer managers already there, and other layer managers have to be manually installed. So for this video, we're going to pretend that we have a couple of mini research projects. First of all, we're going to pretend that we're interested in looking at how rare or common words are in our data. And we're also later on going to look at filled pauses in our data, filled pauses like etc., while the participant is hesitating in their speech. To start with, we're simply going to annotate each word token in the database with the count of how many times the word appears in the database. First of all, we're going to create a new project called frequency. So we go up to the projects menu option. You can see a list of projects there. We've already created one in a previous video. We're going to create another one called frequency. Click new. And now we're going to add a new layer. So what we're going to do, this is going to be a word tag layer, so we're going to click on the word layers option on the menu. We can see a list of word layers here, and we're going to fill in the form at the bottom to add a new layer. This is going to contain the frequency information of the within the corpus. The frequencies are going to be numbers, so we're going to set the layer type to number. They're not aligned, they're just word tags. This time we're going to set the layer manager to be the frequency layer manager. We're going to make sure that that is always generated. Select the project to be the frequency project we just created, and we'll add a description in here. Now we click the new button to add the layer. And now we need to configure the layer. Now we want to summarize the orthography layer, so we'll just leave that selected. We want the scope of the summary to be the corpus, so we want to count up the number of times each word type appears in each corpus. Probably do that for main participants only because we're not too interested in interviewers' utterances. And we want it to cover both of the transcript types, so we'll leave both those ticked. We'll click save. And now we can decide whether we want to regenerate the layer data right now, so we'll click regenerate. And you'll see here a progress bar that goes across as the word tokens in the database are updated. Now each word in the transcript is annotated with a count of the number of instances of that word within the corpus. To see what that looks like, we're going to go up to the transcripts menu. we're going to click the first transcript in the list. And here we can see the transcript. Now on the left you can see there's a projects heading, and under that we can see our frequency project. We're going to tick that to reveal the frequency layers. As you can see under layers we now have the frequency layer that we just created. If we tick that, then it will be displayed in the transcript, and you'll see that each word token is annotated with a number. So for example, the word R appears 27 times in this corpus. The word vivid only appears once. Now these newly generated annotations are also searchable. So let's click on the search option on the menu. We're going to search everyone. Layered search. We're going to tick our frequency project and tick the frequency layer and click Set Search Matrix. Now you'll see that unlike the previous search example that we saw, there are two boxes, and these are not for putting in regular expressions, they're for putting in numeric values, because this is a numeric layer. When we created it, we specified number as the type. So what we want to do now is we want to find out which words appear in their corpora only once. So we're going to add in here the correct number values for identifying that. It's going to be greater than or equal to 1 and less than 2. We'll do that search. Once you've got the search results, you will notice that next to the CSV export button, there is an options link. If you click on that options link, you can see that you can tick or untick layers or other information that you might want to include in your CSV file. So if you click on CSV export, save the results to the CSV file and open it, you can see that there are various columns that have been added. Got the gender column that we just added, and also a couple of columns for the frequency. The match frequency lists the frequency of each word that was matched in order. So in this case we matched two words, the and earthquake, and so the frequency of the is 706 and the frequency of earthquake is 69. The target frequency column contains a single frequency, in this case the frequency of the first word that matched the pattern, i.e. the. The frequency layer manager also keeps a straight word list with word counts for each corpus. If you go up to the layer managers option on the menu, you find frequency layer manager in the list and click on the extensions button. You can see here that you can select a corpus, for example QB, click export, and it will give you a CSV file that contains a list of token types and their frequency counts in the database. As I mentioned before, although it might be useful to have word form counts, it also might be interesting to lump together different forms of the same stem and get frequency statistics from that. So there might be only one instance of the word damaging, but there might be also more instances of the word damage, damaged, and damages, and so forth, and we want a frequency count for all of those lumped together. In order to achieve this, we first have to stem all of the words in the database. That is, reduce all the word forms so that the tokens like damaging, damage, damaged, damages, and so forth all have the same stem annotation. Then we can gather the frequency statistics from those stems. The Porter Stemmer Layer Manager is one way to achieve this. First, we need to install this layer manager, which only works on English data, and so that's not installed by default. So we're going to go back to the layer managers option on the menu, and at the bottom you can see a link that says list of layer managers that are not yet installed. We're going to click that. There are a number of layer managers here. We're going to look for Porter Stemmer and click its install button. We're going to install it. And once it's installed, there's a bit of information about the stemmer, how it works, that might be interesting for you to read. So now we're going to add another word layer. We're going to click on the Word Layers menu option, scroll to the bottom, and fill in some details. This is going to be a layer that includes the porter stem of the words. That's a text layer. We have to select Porter Stemmer as the layer manager. And we're going to add that to our frequency project. When we click New, we don't have to configure anything, so the layer is just generated directly. Now, we'll have a look at what that looks like. Go up to the Transcripts menu option. We'll select the first transcript again. We'll tick our stem layer. You'll notice that each of the word tokens has been marked with its stem. You'll notice that although the stems are not what you might regard as being the lemma of each word, that is, not necessarily valid words of the English language themselves, they nevertheless generally strip off the plural and third person present suffixes and so forth, so that different word forms of the same lemma have the same stem. So for example, the word going has a stem of go, and so does the word go. Now that we've generated a layer of stems for word forms on the orthography layer, we can generate frequency data from the stems as well. So we'll do that now. We're going to click on the Word Layers menu, and we're going to add another layer that calculates frequencies. Stem frequency for the corpus. Again, these will be numbers. Again, we want that to be managed by the Frequency Layer Manager, and we're going to put that in the Frequency project. We'll click the New button, and as we did before, we have to configure the layer. Now this time, instead of summarizing the orthography layer, which is word forms, we're going to summarize the stem layer. It's for corpus, main participants only, and we'll generate that data now. Now when we do a search of this layer for rare words, we will find that the words appear to be a bit rarer than they did before. At least we shouldn't find that the word damaging appears in the list. And so it doesn't. Now we're going to create some automatic annotations of a different kind. Let's suppose we're interested in filled pauses. Hesitation words like and so forth. We can actually identify such words using regular expressions. What we're going to do is we're going to do a search for the word ah. You can see we've got 27 hits there. Now I'm just going to do another search for the word ah spelled with two H's. And you can see there are lots more hits there. So what we've got in our particular data is that this particular filled pause has been transcribed in different ways. But that's okay, because regular expressions can help us with that. If we do a search for some number of A's followed by some number of H's, then that should catch all of the different variants of this particular filled pause. You can do the same thing for some other filled pauses. For example, there's only one instance of the word but if we search for any number of m's, or at least two m's, then we get a lot more hits. So as you can see, if we're interested in identifying filled pauses like this, we can use regular expressions to help us. Now we could annotate these filled pauses by searching and annotating with CSV files as we've seen before. However, there's actually a layer manager that can do it for us, for all existing data and for any new transcripts that we might upload in the future. It's the pattern matcher layer manager. So we're going to create a layer with this. First of all, we're going to create another project called pauses. And now we're going to create a new word layer. This layer is going to be of filled pauses. And it's going to be managed by the pattern matcher. I'm going to put it into our pauses project. We're going to click on the new button. Now we need to configure the layer. Now we're going to match against the orthography layer, so we're going to leave that as it is. And below this you can see a currently empty list of mappings. On the left there will be a regular expression that we're going to enter, for example our R matching expression. And for each of those that we find on the orthography layer, we're going to annotate it with this label. We're going to add a couple more, so we're going to click the plus button. We're going to add one for two or more M's, and we're going to annotate that as being MM. And we're also going to annotate Now if I click save and regenerate, it will go through all the tokens in the database and annotate them. We'll go and see what that looks like in a transcript by clicking on transcripts. We'll click on the first one. Now we are now interested in pauses. We're going to tick our pause layer. And you'll see that each filled pause here that matched the regular expression has been tagged and so forth throughout the transcript. Now that these filled pauses are automatically annotated, there are various things that you might want to do with these annotations. You can search for them as you can search for any annotations in order to collect statistics or study their context. In fact, we can use another layer manager to automatically count them for each speaker and for each utterance in the transcript. In order to do this, we're going to create a meta layer. A meta layer is one that can contain annotations that go over groups of words as opposed to individual words, and can also annotate participants with information. So what we're going to do is we're going to go to the meta layers option on the menu. Here you can see various meta layers that already exist, including utterances, which partition up the transcripts. We're going to add another layer here called filled pause count. It's going to be a number layer. And it's going to be managed by the statistics layer manager. Put that in our pauses project. We're going to click new. And here we have to specify the configuration of this layer. Now the layer that we want to summarize is the pause layer, the one that we just added. We want to count them, so we want to select token count. We're probably only interested in main participants only. And we want to annotate utterances, and we also want to annotate participants. Now, just before we save that configuration, I just want to remind you that on any page where this question mark appears, you can get online help information. So if you're interested in what the options of this layer configuration mean, or indeed on any of the layers, you can click this and it will give you some more information about the options, what they do, how they work, and so forth. Now we're going to save this configuration. I'm going to generate the data. Now we're going to see what that looks like in a transcript. So we'll click on transcripts. We'll again select the first in the list. Now we're going to tick our new layer, pause count. And you'll see that for each utterance that includes a pause, there's now a spanning annotation that counts the number of pauses in there. This has got 2 pauses, so that's a 2. This has got 3 pauses in it, so that's a 3, and so forth. So each of the utterances have been annotated. And the participants have been annotated too. If I click on the participant's name to open their participant attributes page, you'll see at the bottom of the page there's a layers link. If you click on it, then you will see the pause counts have been annotated against the participant as well. Now both the local utterance count and also the participant's overall count can also be exported to CSV search results files. So what we'll do is we'll do just a quick search that involves our new pause layer. Let's look for any pauses. And you'll see on the CSV options, we can select pause count as being something that we export to the CSV file. Now when you open the file, you will see that there are various pause count columns. There's the target pause count for the speaker. There's also one for the speaker in the transcript, but we didn't tick that option, so there's nothing in that column. Neither did we tick the target pause count for the transcript. And this is the pause count for the utterance. Now the Statistics Layer Manager can also incorporate time information in its computation, so it can be used to compute speech rate. We could use it in our example database right now to compute words per minute for utterances, turns, speakers, and so on. However, normally speech rate is expressed as syllables per minute or syllables per second. We don't have any way to get syllable counts for our words yet, but we'll be doing that in a later video. So in this video you've seen how layer managers can be used to compute new annotations automatically from existing annotations. Words can be tagged with their frequencies in LaBB-CAT. Words can be tagged with their stem using the porter stemmer. Words can be tagged with annotations on the basis of regular expressions. And groups of words can be tagged with aggregated information like word count or rate over time. Thank you very much.